Okay, so basically, we're going to start on linear inequalities. As a reminder, just by saying just linear, I am referring to a line, so behavior of a line that we are going to be looking at. Um, in a line, it can be named X, Y, Z, whatever, but at the end of the day, it's going to have a straight line. We're not looking at some curves or anything. We are looking at a straight line and behavior of that line. What are the answers that we are looking at? So when we are looking at inequalities, we are referring to greater than sign, less than sign, greater than or equal to, or less than or equal to. I know it's a silly way of reminding everybody just what you from elementary school, whatever. Always the opening goes to the larger. So this opening goes to the larger side, or whatever the if we have it in that side, it would, and the opening of the inequality sign always opens to the larger side, and the pointy sides, it points to the smaller side. Okay, so before we get to the details of inequalities, let's do some problems that are friendly, and we'll take it a little bit at a time. So as an example, if I have 5x plus 7 is equal to 22. So for x, what is x? All right, let's come on, let's go. What is x? Or how do we solve this?
Subtract 7 from both sides.
There you go. So take away 7, equally take away 7 from both sides, and I would end up with, then what do we do?
You can divide 5 by both sides.
Divide both sides by 5, then I end up, I can read the chat also. If you guys want to write something, I can always see that one also. So we have x is equal to 3. So when we say x is equal to 3, I'm referring to a number line that's called x. From this x, for now, let's go ahead and say it goes from negative infinity. Let's go ahead and say 0, 1, 2, 3, 4, negative, 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 1, 2, 3, 4, 5, 6, and then it goes to positive infinity. So the number line that is called x from this one, where what would satisfy this given equation, it is when x is equal to 3. So we have only one answer, which means if I go ahead and plug in the number 3 in here, the left side should be true to the right side, which is a statement that the statement says 5x plus 7 is equal to 22, which means if x is 3, 5 times 3 becomes 15. 15 plus 7 is 22. That is true. But if I pick any number on this side, or anything in any number on this side, it would not be true. As an example, if I plug in any number on the left side, let's say right here, I have 2. 2 times 5 will be 10. 10 plus 7 will be 17. Is 17 equal to 22? That is false. If I plug in 5, 5 times 5 is 25. 25 plus 7 is 32. Is 32 equal to 22? That is false. So we have how many answers? We have only one answer. So that would be my answer when it comes to this type of questions. But when we are dealing with inequalities, I'm going to look at the same question and we're going to change a little bit. So we have 5x plus 7, 22. So I have 5x plus 7 greater than 22. I'm going to change over here, 5x plus 7 less than or equal to 22. So the steps are going to be very similar, but my answer is going to change a little bit, meaning whatever that we did earlier is going to be the same. So I'll end up with 5x is equal to, not equal to, I apologize for that. So it will be greater than 15, and then we divide it by 5, divided by 5. Then I end up with x is greater than 3. On the right side, the same thing happens. Take away 7, take away 7. I have 5x less than or equal to 15 divided by 5 divided by 5. Then I have x is less than or equal to 3. So this is known at this time is known as my answer in inequality form, meaning this is my answer in that's my answer in inequality form. So if I leave my answer in that format right here, that's my answer in inequality form. But if I come back and look at a number line, at this time, I'm not interested in writing every other number. The only number I'm interested is with the number 3. So if I'm only interested with the number 3, so this would be, number 3 would be dead in the center. The other two that I'm interested would be negative infinity and positive infinity. Negative infinity, and I have positive infinity. So on the left side, if you want to check, it should be a little bit straightforward, but at the same time, if you want to double check your answer, always use a test points. Test points are where you can say you have a numbered line. The number line is cut into two. It is before and after. So you can pick numbers that are before and pick that are numbers that are after to see which one would make sense. So when we check, we always check using the original problem. So always we come back and check using the original problem. So if I come back over here and say test points, so the black is my answer. The red is just for me to double check what I'm doing. So I want to pick a number over here as a test point, a number over here as a test point. So anything before 3, let's go ahead and say 0 is available. I'll take it because 0 times any number would be 0. After 3, I can use 4, 5, whatever. Let's go ahead a little bit exaggerated. Let's go ahead and say 10. Over here, it doesn't matter. You can pick another number. Let's go ahead and say negative 3. On the right side over here, I'm going to pick, let's go ahead and 7. Okay, so on the left side, if I plug in 0 using the original problem, which means if I plug in 0 right here, what happens? 5 times 0 becomes 0. 0 plus 7, it becomes 7. Is 7 greater than 22? That would be false. So anything that I plug in on the left side of 3, it would become false. What about if I plug in 10? If I plug in 10 here, what happens? 5 times 10 is 50. 50 plus 7 is 57. 57 is greater than 22. That would be true. So my answer, I'm going to shade the true side. So when I shade the true side, the graph starts from what? The shaded area starts from 3, and it goes all the way to infinity. So since it is from 3 to infinity, I have to remember infinity is always a parenthesis. 3, because of this, at this time, it is not equal to, so it's going to be also a parenthesis. So this is known as my answer in graphing form. On the right side, the same type of question, but when I plug in -3, what happens? When I plug in -3, 5 times -3, it becomes -15. Is -15 plus 7 becomes -8. Is -8 less than or equal to 22? That is less than. That would be true. On the right side, I have 7. When I plug in 7, what happens? 5 times 7, 35. 35 plus 7, 42. 42 is less than or equal to 22. That becomes false. So my answer is the true side. If I'm using the true side, I'm going to shade the true side. As I said earlier, infinity will be always a parenthesis. But this time, I have less than or equal to, meaning because the equal to, it becomes a bracket. The reason it's a bracket is the number 3 is acceptable as part of the answer, meaning if I plug in number 3, would that work? 5 times 3 is 15. 15 plus 7 is 22. Is 22 less than or equal to 22? It is equal to, so number 3 is acceptable as part of my answer. So it is bracket. On the left side, over here, number 3, I cannot accept it as a part of my answer, meaning if I plug it here, 5 times 3 is 15. 15 plus 7 is 22. Is 22 greater than 22? That is false. It's not greater, it is equal. So because of that one, parentheses means get closer to the answer, but do not use that answer. So what are the part of, what are my answers? My answers are, is not like the above question that I have over here. What is my answer? My answer was just one number. On a number line, it was just one single number. Now, when I'm dealing with inequalities, my answer actually is not one number. My answer is infinite numbers. It's a range of numbers. It starts from, if you're looking at the left side, my answer starts from 3 and it goes all the way to infinity. Any number that I pick on the right side of 3, it would make my statement, with the original problem, it will make my statement true. On the left side, if I pick any number from -infinity all the way to 3, any number that I pick, that will make my original statement true. So the answer is always, it's not just going to be a single number, it is a range of numbers. From here to here, from here to there, that will be my answer. So again, the graphing form, it's only the black. Red is just for me to know which side that I'm shading. But when we are writing our answer in inequality form, in graphing form, and our third one is by looking at on the left side, the graph starts from where? It starts, the shaded area starts from 3, and it goes all the way to parentheses. So we use a comma to show the shaded area. So from 3 all the way to the infinity. Infinity is always a parentheses, and since the nature of this question, now it is only a parentheses, it's not included, so it would be also in parentheses on this side. For the one on the right side, my answer starts from -infinity, comma, and then it goes all the way to +3. Infinity is always a parentheses, but this time, because it is equal, since it is equal, this will be a bracket. So this portion is known as my answer and interval notation. So we have 3 ways that we can answer it. If the question says write your answer in an equality form, the first portion, I'm done. If the question says write your answer in a graphing form, then the second portion, I'm done. If it says write the answer in interval notation, then I have to show my answer using interval notations. So the brackets and parentheses and so on. I'm going to explain those 3 with different scenarios, but up to this point, is there any question?
No.
That's one. Another person. All right, thank you. So again, don't let the 2 people that say no question dominate. If anything is not clear, I'm going to be only listening to the people who are saying something. So please let me know. Insert boxes. Let's go with the boxes. Okay, so let's go ahead and look at these three. So we have those three: interval notations, graphing form, and inequality form. So as an example, from negative infinity to 5. Negative infinity to positive 7. All right, those two to start with. In a graphing form, again, as I said earlier, I don't care about any other numbers. I'm focusing only on the number, which is number 5. The others that I'm only interested would be negative infinity and positive infinity. This one says shade between negative infinity to 5. It says shade between negative infinity to 5. This would be the area that I'm going to be shading. So if I shade and then also the parentheses, it tells me that it's going to be from this side all the way to this side, and that would be my answer in a graphing form. But if I am thinking about that portion is the x side, so I have x and the number will be number 5. So if the number is 5, x in relation to number 5 is what? So you have to pick a number just to do, if you want to double check. Let's say on the left side of 5, if I say negative 3, if I plug in negative 3 over here would be what? If I plug in negative 3 and I try to read it, it would be negative 3 is greater than or less than. It would be negative 3 would be less than 5. That would be my answer. So when we are trying to check, always plug in a number that is from the shaded side and you should be fine. The next one over here would be same scenario, negative infinity, positive infinity, but this time I'm only interested with number 7. So this time it says shade between negative infinity and 7. Okay, fine. I'm shading between negative infinity and 7. But it says infinity is always a parenthesis. But 7 on this side, it tells me it is a bracket. If it is a bracket, that tells me it's going to be included. So I have x and the number 7. If I'm thinking about the shaded area will be my x region. So that region comparing to 7, let's go ahead and say 0. I don't care. It is on the left side of 7. So 0 in relationship to 7, it would be also what? It would be 0 is less than 7. But this time, since it is bracket would be equal to. So that is one thing that I have to remember. If it is bracket, everything is a parenthesis except it is greater than or equal to, less than or equal to, it would be a bracket. Another one, let's go ahead and facing the other way. Negative infinity, positive infinity, negative infinity, positive infinity. The two numbers that I'm interested, for the first one will be number 3. The next one will be number 4. It says shade between 3 to 8 to infinity, sorry. It will be I'm shading between 3 to infinity. And this one says shade between 4 to infinity. But one thing I know, infinity is always a parenthesis. 3 is a parenthesis. Number 4 is a bracket. Bracket means number 4 is included. So over here, my shaded region would be the X, would be my shaded region. So I'm looking at the relationship between X and number 3, the relationship between X and number 4. If I'm picking a number, let's go ahead and say 10. 10 in relationship to 3 would be what? 10 is greater than 3. That would be my answer. On the second one, if I plug in again 10, 10 in relationship to 4 would be 10 is greater than 4. But this time, since number 4 is included, the greater sign will have a greater than or equal to. Any questions so far?
Nope.
Okay. Okay. All right. And sometimes we have not infinity, but we have numbers. So let's go ahead and say 2 and 9. Let's make it a negative. It doesn't matter. Parentheses to parentheses. 5 to 14. Parentheses to bracket. And bracket -7 to 12 parentheses. Data space. Okay, so if we are looking at those scenarios, negative infinity to positive infinity, again, as habit, but I'm looking at two numbers this time. Let's get lazy a little bit. Copy and paste it. Bring it here. Copy and paste it. Bring it here. Copy and paste it. Okay. On the first one, I'm only interested between 2, -2, and 9. And it tells me shade between -2 and 9, and that will be fine. The next one, it says between 5 and 14. 5 and 14. Again, all of them are going to be shaded in between because it is a region in between. The next one is going to say between -7 and 12. I'm going to shade in between. The next one, it says between 5 and 16. So the one I have to be careful is if it is parentheses, then it becomes just a parentheses. If this one is a parentheses, but this one is a bracket. This one is a bracket, and this one is a parentheses. And this one is a bracket, and this one is also a bracket. So the shaded region is my X. So I am referring X in relationship with between -2 and 9. Between +5 and 14. -7 and 12. 5 and 16. So if I'm going to focus on those numbers, now any number in between that I pick, it would be my, if you want to double check your answer, always pick a number. If I say X is between this and that, let's go and say 5. So if I plug this one as 5, it will be -2 is less than 5. 5 is less than 9. And since both of them are parentheses, that would be my answer. The next one, let's go ahead and use the same number again. Okay, can I use 5, 7? So we have 5 is less than 7. That is true. 7 is less than 14. That is true. But this time, I'm looking at the right side. It is a bracket. So the bracket would be less than or equal to. Question? Okay. The next one over here is between -7 and 12. Let's go ahead and say 2. If I plug in 2, what happens? -7 is less than 2. 2 is less than 12. But this time, -7 is included because it is a bracket. The last one, between 5 and 16, let's go ahead and 10. 5 is less than 10, true. 10 is less than 16, true. But this time, both of them are, the left side and the right side are, both of them are brackets. Or since they are brackets, then it becomes less than or equal to, and that will be the way we solve the problem. So again, this is the way we write the question. Sorry, we write our answer depending what is asked. If the question says write your answer in an equality form, then we will leave it on the like the one on the right. If it says write your answer in a graphing form, then we would do it like in the middle. And if it says write your answer in interval notations, then that would be like the one that is on the left. So I know this is a little bit too much, but just in case, how it applies is when we are solving a problem, we're not doing everything. We're doing just like one or the other. Okay, so let's go ahead and say 3x plus 5 is 19. Let's go ahead and say 26. Okay, so we have two questions. The first one should be straightforward, like we did a little bit, and the one that's on the right side a little bit different from what we are talking about. Okay, so on the left side, take away 5, take away 5. It should be equally, what do we have? 3x less than 21. And then we go ahead and divide by 3, divided by 3. Then my answer should be x is less than 7. That is my answer using inequality form. If I have to graph it, negative infinity, positive infinity, the number in the middle would be number 7. Again, if you are using test points, you want to double check, then you can go ahead and check your answer. So as a test point, if I plug in 0 on this side, if I plug in over here, let's go ahead and say 50. I don't care. As long as it is on the right, you can confidently plug those numbers. So remember, any number that we plug in, it goes into the original problem. So 0 times 3 becomes 0, plus 5 is going to be 5. Is 5 less than 26? That is true. So I am going to be shading the one on the left side because that side is true. But the 50, 3 times 50 becomes 150. 150 plus 5 becomes 155. Is 155 less than 26? That becomes false. So I'm shading the left side. The only thing that I have to remember is infinity is a parentheses. 7, since it is this side over here is just less than, then I have to make sure that is going to be, and that will be my answer in graphing form. So the shaded area starts from negative infinity, and it goes all the way to number 7, from there to there, and that will be my answer only using interval notations. Similar question, but before we start doing that one, I want somebody to walk me through with this question. What do we do on the one on the right side? NECA.
Subtract 4 both sides.
So subtract 4 equally from both sides.
Divide out the -2.
Divide by -2. And I have what?
-6.
X
Less than or equal to.
Right? All right. So thank you. But let's go ahead and look at this, everybody. I'm going to get -8 and 24. All right. Somebody give me the answer. Greater than or less than? What goes in between? -8 and 24. What sign goes in between?
Less than.
Negative. Yeah, less than.
Less than.
It should be less than, right? All right, so let's pay attention over here. If I multiply this by 2, I get -16. I get 48. What sign goes in between?
Still less than.
Less than. All right, let's go ahead and say if I divide this side by 4 and divide this side by 4, I get -4. On this side, I get 12. What sign goes over here?
Less than still.
Less than. All right, so what happens? So what happens if I multiply by a positive number and divide by a positive number? Nothing happens to the sign. But the same question, let's go ahead and change it a little bit. I'm going to ask greater than or less than. So I have -8 and 24. What sign goes in between? Everybody said less than, right? So, but this time, if I go ahead and multiply this by -2, multiply this by -2, negative and negative becomes positive 16. 24 times negative, it becomes -48. This time, what sign goes in between?
Greater than.
Greater than. And then if I go ahead and divide it by -4, if I divide by -4, 16 divided by -4, it gives me -4. -48 divided by -4, or -4 will give me +12. What sign goes in between?
Less than.
Less than. So now what I'm trying to establish over here is if I multiply or divide by a positive number, sign, nothing happened to the sign. But if every time I multiply or divide by a negative number, what happens? The sign flips. So when we are trying to solve a problem like what we just did over here, I have to pay attention right here when I am dividing by -2 So what happens? This sign that I have over here must change. Does that make sense? So the sign that was less than or equal to, it would be greater than or equal to. So that would be my answer in what form? In inequality form. So please note over here, when multiplying or dividing by a negative number, inequality sign So whenever we multiply or divide by a negative number, inequality sign flips. So now that I have this answer using a number line from negative infinity to positive infinity, the only number I'm interested in is -6. And between -6, now I can go ahead and pick a numbers. If I'm trying to see test values, give me a number on the left side, give me a number on the right side.
Four.
I didn't hear you, sorry.
4.
Where?
On the right side.
On the right side, I pick 4. On the left.
-10.
-10 will be safe. So if that confuses you, always remember that over here, what do we have? This is -5, over here -4, over here -3. Over here it is -7, -8, -9. So if that helps you, always, whenever you're dealing with negatives, just then play with that marking, just like to pick the right numbers. So it says x is greater than -6, greater than or equal to -6. Then let's go ahead and plug in -10. Again, we are plugging in into the original question. If I'm plugging into the original question, -10, 2 times -10 becomes negative, and negative becomes positive. 2 times 10 becomes 20. 20 plus 4 becomes 24. Is 24 less than 16? That will be the false side. What about if I plug in 4? What happens? 2 times 4 becomes 8. 4 minus 8 will become -4. Is -4 less than or equal to 16? That will be true. So I am going to shade the true side. Meaning any number from the shaded area, if I plug it into the original question, it should make the left side equal or true to the right side. So one thing that I have to remember is now this portion over here, it says it is greater than or equal to. So because of that one, then I have to make sure that it's not going to be just a parentheses. It should be what? A bracket. So from the bracket to parentheses over here. So my answer, technically, it is from what side to what side? It starts from -6 and it goes all the way to infinity. Infinity is always a parentheses. -6 is what? A bracket. Any questions so far? Yes, no?
No.
Okay,
No questions.
all right, thank you. The next one will be So compound inequality. Compound inequality is basically you have more than one equal signs in a certain given question. So if I have, let's say, -7 is less than, go ahead, equal to 2x minus 5, 16. So if this is given, this is known as a double inequality. Double inequality means it is like it's a compound inequality. We have two sides of the equation. So what we do is whatever that I do to one side, I can do it to the other side. So my goal is to have the x in the middle. So since I want to have the x in the middle by itself, same thing that we just do with the other problems, add 5, add 5, add 5 equally to all sides. What do we have? -7, 5 becomes -2, less than or equal to 2x, less than or equal to 16 plus 5 would be 21. And then we go ahead, divided by 2, 2, 2. So what do we have over here? It becomes -1, less than or equal to x, less than, over here I made a mistake, nobody saw this one, we're just less than 21 divided by 2. If you want to write it, you can write it as 10.5 or 10 and 1 over 2, doesn't matter. So this will be my answer using inequality form. So if I have to graph this one, I'm looking at from -infinity to +infinity. This time I'm interested only with two numbers. So on the left I have -1, on the right side I have 10.5. So after a while, less than, you will notice that it's going to be always shaded in the middle. But if you want to double check, always use your test points. So if you are using your test points, over here, over here, over here, I will pick a number. On the left side, I'm going to go a little bit crazy. I'm -10. On the right side, I'm going to go all the way to +15. In between negative and positive number, if 0 is available, I'll always use 0. So if I plug in these numbers into the original question, meaning right here, so if I plug in -10 into the original question, I'll get -10 times 2 becomes -20. -20 minus 5 will be -25. So it would be -7 less than or equal to -25 less than 16. So which side is -7 less than -25? Already over here it is false. So this is the false side. What about if I plug in 0? If I plug in 0 here, 2 times 0 becomes 0, and then I have -5. So it would be -7 less than or equal to -5 less than 16. -7 is less than -5. That is true. -5 is less than 16. This is true. So this is. What about 15? 15, 2 times 15 becomes 30. 30 take away 5 becomes 25. So we have 25, -7, 16. -7 is less than 25. True. 25 is less than 16. It is over here. It is false. So which side is true? The true side is right in the middle. So I'm going to shade the middle side. So now that I'm shading the middle side, I have to pay attention to the endpoints. The endpoints over here, one of them is less than or equal to, the other one is just less than. So since it is less than or equal to, becomes a bracket. The other one, it says just less than, it becomes a parentheses. So based on this one, my interval notation answer would be, the answer starts from, my solution is from -1 all the way to 10.5. So it would be bracket on the left side. On the right side, it would be a parentheses. Any questions so far? I didn't hear. I heard a little noise, but I didn't hear. All right. Thank you, Sebastian. Okay, so everybody, please pay attention here. As I said earlier, we are not rushing this. So we only did, you should be able to do number 6 and 9 and 13. From 16 all the way to the end, we are going to cover that one on Friday. That is going to be absolute value inequalities and a little bit of compound inequalities. We're going to do that one on Friday. So for today, you are going to be doing 6, 9, and 13. Where is the book? Okay. Number 6, number 9, and number 13, it should be the problem that you're going to be doing for today. The other portion, it should be for next class. So over here it says homework. Homework number 5 is due Friday. I'm going to change this one. It's going to be homework number 5 is going to be due on Monday. So when we are clear between the next section is going to be, which is absolute value inequalities, then everything, the homework from today and the homework from Friday's class, everything should be due on Monday. So you can submit it whatever you can, but they're not going to be 2 submissions. It's going to be 1 submission. It's going to be due by Monday. If you have any question, I am here. Is Treasure here? I see you. All right. Emeka Jones, are you here?
I'm here.
Okay. Rebecca? Lauren? I thought I saw you earlier. Lauren, are you still there? Okay, when I'm calling people, if they're not here, I'm just going to mark them absent. Do. Mediani, I see you. Okay. So it should be clear. If you guys have any question, I am here. I'm going to post the video as soon as possible. And let's go ahead and start recording. Okay, if you guys have any question, I'm here. If not, you can log off and I'll see you guys on Friday.
Thank you.
Thank you.
Bye.
Take care.
Anika was still here.
No,
Bye.
you're not.
Yes, I was.
No, you're not.
Bye bye. Have a good day.
Take care. Lauren, are you still there? If you logged in and not there, then I have to mark you as an absent.
Hello.
Yes, I'm not.
What I was gonna say. When we do the homework, where do we send it to? Like,
I sent it to you, the clip. You didn't see, you didn't reply. I sent you the information, right?
what date?
You asked me for the via email.
Oh yeah, yes you did. Yes you did.
Yeah.
You did.
Let me see.
You have a good one.
Hold on. Yep, and I responded to you how to respond it and so on. So again, I don't know if you can still see my screen.
No.
You can see the screen, right?
Yes.
So the homework. So when you click over here,
Yeah.
right? So whatever the assignment that you finished from this portion, whatever, let's say for today, I don't want to say today, from the other day, from Monday's class. If you are trying to submit these questions, then you come to homework, and then that would be homework number 4, which is due today by noon. If you click on that one, it should give you view assessments. Once you click on that one, it should, and it looks like you cannot do anything over here, but when you click over here, it should allow you to attach your pictures and so on.
Also, like a attachments that's already in the computer with the picture of the work.
You can do it on your phone if you can take a picture, or if you're using scanner.
Yeah, I could take a picture and send it to my email, then put it on the computer as an attachment, then put it there.
Yeah.
All right.
All right.
All right.
All right. You take care.
You too.